Hello, it's Monday night, and it feels like everything is crashing around us. The last hour has been a disaster, but we're going to push through, and we're going to do Let's Make It. We're going to talk about memory management in the Arduino, and also we're going to build a web server with an Arduino. Right after this. Well, hello, and it's time for another Let's Make It. However, this is not Monday night. This is Tuesday night, because last night I was feeling very ill. Actually, I'm still feeling not so great, but I'm going to power through it tonight. Some kind of stomach thing going on. At least the headaches are gone, so I'm feeling a little better that way, but the stomach still isn't quite normal. So, and this has been an interesting evening so far. In the last hour, just about everything you can think of has gone wrong. So let's just hope that the show continues without too many issues. I am having problems with the stream. For some reason, my internet is not stable. I cannot stay in the chat room. I keep getting disconnected from it. The streams are going up and down. When I walked in here, they were up for the moment, but they could be back down again, so I don't know. Bob tried calling me a few minutes ago, and I couldn't connect to him. I've rebooted that machine, and hopefully he tries calling back in again, and maybe we can get connected. But I have a feeling I'm having internet issues. So if you're on the stream and it drops off, I'm sorry. I cannot control what happens on the internet, unfortunately. However, I can control what happens in here. Well, no, maybe not. Over the last hour, I've had a couple of machines crash. I've had a bunch of weird little issues. So maybe I cannot really control what happens in here. So we'll just hope for the best. Like the sky has been falling for like the last hour. Everything was going good all day until like an hour before the show. So this week, well, first of all, I'm listening for Bob in my ears. You won't hear him ring in, but if he calls in again, I'm going to try to answer him. So we'll hopefully he'll try to call in again. Just hope he doesn't think I'm ignoring him. I can't answer the phone. So or can't answer Skype for whatever reason. So this week we're going to cover some memory management and a web server, and they kind of go hand in hand, and I'll explain that along the way. But before I get started, I want to make sure I thank everybody again for using the Amazon link. If you need to buy anything on Amazon, our link is still valid. It's not a lot of money. It's like 1 or 2% of the sale, 3% maybe, something like that. So it's not a lot, but every little bit helps us to get the new Arduinos and the new little things that come out we're going to start talking about here. It just helps us to fund that equipment, our hosting costs, things like that, because we pay that out of our own pocket. Also, I want to thank you for telling people about the show. The show has been growing like crazy, and that's a very good thing. We're getting lots and lots of emails. In fact, I caught up about on 6 to 8 of them probably today. I still probably another 12 to catch up on, but I've gotten 4 more just today. And so I definitely appreciate that. We will get back to you. We're a little slow getting back, especially me personally recently, because other projects I'm working on, about the switcher thing. It's, getting ready to try to get into production. But we will answer you back, and if it's a simple thing, we'll answer back pretty quickly, but it's a little more involved. May take a little bit longer. We also gotten some requests from some shows. They are on our schedule going forward. There was one where they want us to go back and redo or go into more detail about something, so we're going to do that. I think it's like 2 weeks out, but we'll talk about that stuff later. All right, before I get started, I want to show you some other things that came in this week. Actually, some things that we've developed. So you hear us always complaining about the backpacks that go in the back because they're always so different. But in reality, they're all pretty much using the same chip, one of 2 chips typically. So what we have done is we created our own. So this is our LCD backpack, and this will work with either 16 or 18. I have 18 on here right now because I was going to put it onto a different kind of display. But basically, it's the same chipset. What we've done a little differently is we have added in the ability right here to address it. Now, it is a default address, and we'll tell you what that is, and we'll document it so that there's no question, and we'll get a library for you so it'll all work without having to go find stuff. That's what our confusion with and our frustration with has been that. Now, we do have 2 versions of it. You'll see this one has 8 pins on the top, and that's because this one is actually designed for the switcher, because our internal bus on the switcher uses an 8-pin ribbon cable to go from board to board to board. So we have a version that's like all the other ones that has the pins on the side that is 4 pins. So it'll be just like the other ones that you're used to seeing. It just doesn't have all the pins that you need, all the extra pins that we use on our bus. So it just makes it easier, but it works exactly the same. And like I said, we're addressing. Actually, I have, if you're using the 8-pin, the 17th, 18th pin on that LCD. The 18th pin is the backlight or the lighting, and we can turn that off and on in software versus having the jumpers. People have jumpers right here to turn it off and on, and we have the ability to do it right here because not all LCDs are programmable with backlighting and controllable. So we have the ability, if you have one that has a separate pin for the backlight, that you can control that here in code versus taking the jumper on off in the end. So we've added that in there as well. So it's very flexible. Now, last week we showed you 16 by 16 board. This is our version. It's not 16 by 16. This is a 4 by 10. And I'm probably going to do different variations of this. But you see a pin right here, and you see a pin right here, or a receiver right there. So those are the in and outs. And then there's also an in and an out here. So these boards can be put in this format and stacked together, or they can be put side by side and stacked together. A typical Arduino can handle about 500 of these LEDs. So you could do a strip, again, this is 40. So you could put, 12 of these, maybe you can get away with 13, side by side or top to bottom, or in any combination of that, actually. So you could actually go, this way and then come down this way. You have to jumper from this end to this end, but you can lay it out in many different ways. If you want to do them horizontally, you can do it like this, stack them like this. So there's many options there. But I wouldn't go much more than 500 of these with an Arduino. It just can't handle the I/O. But 500 is actually a lot. If you think you get 12 or 13 of these boards in a row and one Arduino handling it. So then we have this one, which looks very similar. Actually, you see this is really just typical board. This looks very similar to that one. It's still the 4 by 10 layout, but it's actually a shield. You see, there's the Arduino. So if you want to play with these, this is something we're going to start selling, I think, that will allow you to play with a matrix. Now, we may do these different sizes too. We just haven't worked it out. And this is actually very dense. If you look at how bright these things are, didn't realize how bright they were when I designed it. I figured it was like little LEDs, but they're very bright. So we can probably spread this out. And we may do more of these that are... maybe this would be like a 2 by 5, and you could do a lot more of these boards put together off one Arduino that way, and it would probably look fine depending on what you're using it for. If you're using it for actual letters, like in an 8 by 8 matrix or something like that, or like a matrix style letter, this is probably how dense you want it, because this is you can see the letters shaped that way. In fact, you may want it more dense than this. However, these are very, very bright LEDs. Now, one thing is it requires quite a bit of power. So if you use this shield, you can't use the USB power from the laptop. It just doesn't. It will not work. So you have to plug in the back. And I don't remember. I figured out what the rating was. I don't know if 2 amps ran this one, or if it required more. I think it required more. I think it required 5 amps, 5 volts at 5 amps, I believe. But this one required to safely run it. That's assuming all LEDs at 100%. So it basically be a white, very bright white panel. So that was some things I wanted to show you this week that we are working on. All right, so one of the things, and I'll change this. I don't need to change it or not change it later. One of the things that I wanted to cover this week is memory management. And this is actually something that bit me in the last 3 to 4 weeks. My switcher that I'm working on, which you have seen, has a web interface, and you can put it in that mode, and you can do some advanced configurations, and all the information is stored in an EEPROM. But that's done through the web interface. If you look at a web page and you look at HTML, it's very wordy, lots and lots of letters. It's not compact at all. And while I was doing that, I was in the middle of developing that, and the Arduino just started locking up on me. I couldn't figure out what it was doing. I thought I had Arduino go bad. So I went, and I have other Arduinos around. I went and grabbed one, put the same sketch up to it, and it did exactly the same thing. It would just lock up. And one of the LEDs would just blink in a weird pattern. And I couldn't figure out what the code meant. So I started looking around Arduino lockups and things like that. And then I realized it could be a memory issue because other people were complaining about running out of memory. So in the meantime, I'd taken things out. If I took some things out, it would work. I put things back, it would not work. I put it back one line at a time. And the line I was put back didn't make sense, that it would cause a problem because it was just echoing out or printing out to the page, HTML code. Didn't make any sense. Ended up being I was running out of memory. And in researching this, I found out how to take that memory and basically just release all that memory. So what I'm going to cover tonight is I'm going to show you how to do that. It's very simple. And most people, I don't think, realize how much RAM is being used by things you have in quotes. So you have a constant, and it's being printed to the serial line or whatever. It's using up RAM, and I don't think most people realize it. So what I want to do tonight is I am going to show you, first of all, what little memory you have, especially on Uno. I've got an Uno here I'm going to show you this with. And then I'm going to show you how you can figure out how much you got left and how you can free it up. So let's go over here, and I'm going to hop over to the computer, and we're going to walk through this real quick. All right, so this is a basic memory management sketch, and let's go down here. I'm going to comment on a few things before we do this because I want to show you what it looks like prior to that. So let me... All right, so basically what we have here is it's something very simple. We include memoryfree.h, which you can go out to and search for that on Google, and I think I got it from the Arduino Playground. And all it is it's a very small header file that has like a macro that just gets some free memory information. So I'm going to put it out to a serial port so we can see how much space I got left. So I'm going to start the serial, and then I'm going to go through this loop. Now ignore what I commented out because we're going to come back to that, and that's how I'm going to demonstrate the memory. So you see me printing to the serial port, let's see, a blank line, and then I'm going to print out how much memory I have free, and then under blank line, I'm going to wait 10 seconds. And that's it. That's all we're going to do. So let me go ahead and upload this to the Arduino. And it is done. All right, so we're going to go do the serial monitor, and you're going to see it come back. And that's how much memory I have left. I have 1.8K, basically 1,831 bytes of RAM left before I am out of RAM. And I'm going, if I sit here 10 seconds, there it goes again. There is 1,831. So as you see, it's never going down. It's very consistent, constant. So let's come over here, and I have right here Abraham Lincoln's 7 years ago speech. I'm going to upload this, and also going to do is going to print to the serial port that speech. So let me go ahead and upload this. All right, let's go look at it. And it's going to be a little slow coming to the serial monitor because you expect it to be for all that text. But however, I want you to see this 349? I just used up that much of my RAM on this thing to print this out to the serial port. That's scary. This little Arduino Uno can barely handle me printing out that speech from Abraham Lincoln. It's almost out of RAM already. So what do you do? Well, this is the problem I was having. I was running out of RAM, didn't realize it. I didn't know what was going on. So if your Arduino is acting funny, look at see how much RAM you have. So what I'm going to do is I'm going to go in here, and there's a macro that's in here. It's called F. So let me comment this out first. So here is the way that I would have done it originally, just like that, and not knowing what was going on. And then I'm going to uncomment this one, which is the exact same thing, but with a macro. Let me upload this and we'll show you the difference. All right, let's come in here to Tools, and we're going to go to Serial Monitor. And you're going to see there's the speech. But look, I'm back to 1,831 bytes of RAM left. So I still have all the text that I had before, but I'm not using any RAM. So let's go look at this one more time. And all it is an F and a bracket. And this is a macro. And we're going to have to cover macros on another show. I've learned a lot about these macros that I never knew before. So now that I know them, there's a lot of cool things I've been doing with them. So we'll come back at some other time and cover macros. So here we do same thing, serial print line, and F, a bracket, and then in quotes, and then a closed bracket. So right here's a short version so you can see the whole thing. So what would normally just be this, like this, all you do is you add in F, just like that. And that puts it into program memory. So basically what the difference is it stores it in program memory. So when it goes to look to send this out, it doesn't go and look in RAM anymore. It doesn't put it into RAM. It just goes and looks in the program space. So it saves you that amount of RAM. So anywhere you use constant in quotes, you can do this. Now, if you think about a web page, think of how much more text there is on a web page because you got the tags and you make it look pretty. You got all the other stuff around it. So it adds up really quickly, and that was what's happening to me. I took a whole mega and ran it out of memory. So before I realized what was going on. All right, so there is one other thing that I want to talk about, and this is mainly for arrays, and this gets a little more complicated. Let me go, and I should have brought this up before the show, but we're going to look up Arduino Prague. You can tell I did that before, probably. Prague mem, yep, been there. And this was actually something that was very helpful as well, because in the website I have a bunch of large text arrays that were also eating up memory. And as I was learning about memory management, I've come across this as well. So it's easy to declare it. So in my case, I was using a two-dimensional array of string, or char. So mine would have been char, and then the name, and then empty brackets like this, and then brackets. And I knew I had like 20 items, so I put 20. And then you put this right here, prog mem. And what prog mem does is it puts this data right here into program space, just like the F does down below. So it doesn't reside in RAM. So if you have large text arrays, that's what you can do to sorry, let me kill this real quick. It's going to drive me nuts otherwise. If you have large text arrays, you can put the data into program memory versus into RAM. Now, there is a couple of caveats with this. First of all, the data type is a little bit different. So let's come down here to the bottom, and you see right here, I think I was using uchar, not char, and it's prog underscore uchar. So if you look down here, you can see where it's defined right here, prog uchar, and they have a single array sign message, and they put it in program memory, and it's equal to, and here you go again, here's the quotes. So rather than using up your RAM, this goes into program memory. Now, to get this back out, though, it's a little more difficult. You just can't set this in as an address. So you have to get the word. So here's a word, here's a byte right here, and you can set your char. So you see program read byte near. Now, there is some shortcut things. I'm going to show you this. This is them doing an array. So you see right here, if you use string copy, it's to get it out of program memory, it's underscore P. And most of the things you have, functions for strings, are also available just by putting underscore P there. And that's basically what you have to do. You have to put it into a buffer somewhere first to manage it. So it's a little bit extra work. But if you're talking about large arrays or a single function that loads an array in, it isn't that much more work. It definitely saves in memory space. So I don't want to go into great detail. This is a little bit confusing, but if you are running on memory space, look at this. After you figure it out, it's not so confusing anymore. It's actually fairly simple. But to get your head wrapped around it, if you're new into C, this may be something you might want to avoid this for a little bit. But if you're at title and RAM, definitely look at it, because it's definitely saves quite a bit of space. Because there's a whole bunch of like string copy is just one of them, but there's a whole bunch of different underscore P type of commands. And if you're questioning about types of memory, there's a link right here. I'll put all these links in the show notes too. This is a good link for understanding memory on the Arduino. So it talks about different types of memory. SRAM or static random is where your variables and everything are kept, flash memory, EEPROM, things like that. So it goes through and talks about all the different types of memory you have here and how it's used. It's actually very educational to understand this, because I didn't understand all this. I assumed it was, I work with things that are lots more RAM. I don't think about individual bytes or 1.6K of RAM. So it was definitely a learning experience for me as well. All right, so let's get back out of this. And I think we're done with this one. So when we come back from the break, we are going to talk about a web server and building a web server, which is where I ran into the problem with this particular issue of being out of memory. So after the break, we're going to put together a web server and show you how to do it. It's actually very simple after you get your head wrapped around it a little bit. There's a couple little things that are different, and the structure of my code's a little bit different because I got things what's around, but we'll work out all that stuff when we come back from our break.
You work hard for your business. Your website should too. No matter what industry you're in, select your customizable high-quality design with professionally written content and graphic elements created for your business. Make changes online whenever you like. Switch your background color, page layout, and text anytime. Add your pictures and logo. Upgrade your website with useful one-in-one web apps. And integrate social media. Upload your photo albums and embed videos. With one click, optimize your website for viewing on mobile devices. Choose your free domain, or you can easily transfer an existing one. Thanks to One-in-One's SEO tools, customers can find you everywhere. One-in-One My Website, a professional website created by you.
When you open up an Audible audiobook, it opens up your imagination. Enjoy a steamy romance while ironing the sheets. Discover an historic battle while battling the bulge at the gym. Visit audible.com/freebooks now to try 2 books absolutely free. Get caught up in a whodunit during a do-it-yourself project. Listen anytime, anywhere with the Audible mobile app. When you're out for a walk, learn how to climb the corporate ladder. Or bring a little magic to your minivan with a fantasy novel. With over 100,000 titles, Audible is an amazing experience that you can now try absolutely free. And just like our books, there's no binding. Our great listen guarantee lets you exchange a title you don't like for another. No questions asked. Visit audible.com/freebooks to download 2 books of your choice right now.
All right. I want to thank our sponsors. They are great. They help to support us, help us to bring this show to you. All right. Before the break, we were showing memory management. And the reason we were showing you is because in this next thing, this next web server demonstration, we're actually going to use it quite extensively, as a matter of fact. So let me go ahead and expand this real quick. And we're going to walk through a web server over on the computer. All right, so here we have our comments. So we start out, and this requires an Ethernet shield. So actually, before I go into the code, let me show you what I'm doing so you don't think there's any kind of special magic. Basically, Ethernet shield on top of an Uno, the same Uno we were using for the first sketch. So right now, what it's doing is sending out memory stuff. So we'll load the sketch up in a little bit here, and it'll be a web server. Okay, so because we're using the Ethernet shield and the way it connects, it requires SPI because that's how it communicates to the Ethernet shield. And then we include ethernet.h, and then we include webserver.h. And these are the 3 things that are required to build a web server. These next 2 are for a demonstration after this right here. So just ignore the wire and DHT, but if you watched some of our previous shows, episode 25 in particular, and there's another episode on sensors, we have a DHT11, which is a temperature sensor, reads it in Celsius, Fahrenheit, and also gives you humidity. And it requires wire.h to communicate. So those are something we're going to use in a little bit. We don't have them hooked up yet. You'll be with us when we hook them up. So, and then for the Ethernet shield, something to remember is they do not come with the MAC address. They're using a WizNet chip, which allows you to set the MAC address to whatever you want. So the MAC address I'm using here isn't really anything. It's in the generic range. I think it is in the generic range. That's what I was told. So I can pretty much make it anything that I want. And as long as it doesn't match something else in your network, it's going to be fine because this is a 32-bit address. Is that right? There was a 48-bit. It's 48-bit address. So the likelihood of you hitting one of those in your own network is pretty slim. So I just picked a MAC address out of kind of random in the free space. Now in my network, my demonstration network is 10.232.1. So I put this for 250. So this is my IP address, because you're going to need to set this before you turn up Ethernet. And then we define web server. And when you define the web server, you have to give it a prefix in the port number. The prefix is something like if you are down in a website, like I'm going to be the top level of the domain, because it's going to be the only thing in there. But if you wanted it to be deeper in the list, like /home/mic/ then whatever, you put that in here as a prefix. So it's not going to be at the top. I don't really care to do that. And then here we're going to define our temperature, and it's on pin 4. And we'll remember that for later, because we're going to plug it back in. And then here's where it's a little different. You see, we don't have our setup in our loop at the top like I normally do it. And that is because I have to define these before I define the web server stuff. So we're going to scroll down kind of the bottom where I do that in the setup, and then we'll come back to the top. So here's our setup. We again, to attach the temperature sensor to pin 4, we start our serial port up because we're going to need that a little bit later. And then we start our Ethernet up, which here's the MAC address and the IP address that we talked about. And then we go to the web server and we say begin. So that basically starts up the process for the web server. And we want to add some things to the web server. We want to tell it what to do when you go certain places. So the default command is if I would go to this is my IP address of this particular device is 10.232.1.250. It's just like if you would go to www.something.com, it would be the top level domain. So this is our default. And what this is the address of a subroutine, which we're going to walk through here shortly. And then I want to add an additional command beneath that, basically. So the command I'm going to create is called page 2. And the way you'd access it is the same http:// or whatever /page 2. And then if somebody does go to there, I want to run this subroutine. So we're going to go look at that here in a little bit as well. And then I'm going to add one more, and it's called form. So if they would go to this web address /form, I want to call this subroutine. So we're going to walk through those subroutines. Now, the loop is the easiest part. All you have to do is call web server process connection. Now, something to remember here is that this is basically a single threaded web server. It isn't like your computer where you can do multiple threads. It can really only do one thing at a time. So that's something to remember about the Arduino. It's not a great web server. It works good for getting some things out of it and doing basic stuff. But if you're looking to serve some kind of content in any kind of volume, this is not the platform to do it in. In fact, the Arduinos are quite slow at doing this. All right, so now we defined our layout, which is default, the page 2 in the form, and we also know default command, page 2, and form command are subroutines. So we're going to walk through these. And too far. Other thing I didn't mention before I get into this is I skipped over what port 80. If you're not familiar with the web and how it works, there's two basic ports, 80 and 443. 80 is clear text and 443 is encrypted. To my knowledge, the Arduino cannot do anything with encrypted data. Not that I've seen it anywhere. I haven't looked in great depth, but over all the things I was doing learning with web servers, nobody was ever doing any kind of encryption. So 80 is the default. However, you can make it anything you want. If you're going to put this on the internet, you wouldn't want 80 because everybody's searching for 80. You'd use something like maybe 8123 or 8, something like that. 8254 or whatever you want to do. Common ports though are 80, 8080, and 8088 are very popular ports to use for that. Your web browser by default will go to 80. So if you want just to be able to use the basic web browser, then you want 80, which is what I'm going to do here. All right, so now we get into our outputs to the pages. So basically the web default view outputs HTML. So all these functions do is whenever somebody goes to that, it prints out to the web server text. So first thing I'm going to do here is I'm defining a variable called HTML head, and in there is basic HTML. So I'm not going to go through the HTML language in any depth at all. I'm assuming that you either know HTML enough to be able to do this, or you can go out and find it. It's things everywhere. HTML is pretty much taught in schools. But basically, it's a markup language. I don't like calling it a language. It's a markup something because it doesn't really do any kind of function. But basically, I'm doing here is I'm defining the HTML, the head. Here's the title of the web page, and then I'm going to set a little style for the page. I'm going to close off the head, and then I go to body. So this is my variable. It hasn't set this out yet. Now, if you look at the HTTP protocol, there's these answer back. So everybody knows what a 404 is. 404 is not found. But when something works good, it gets a 200 back. So we need to send back the success message of 200. So that's what this does right here. Server.http success says we are successful. Here's a 200 back. And then I'm going to send out to the client what I just put in this variable up here, which gets me into the body. And then I'm going to start printing out the rest of the page. And this is going to be a very simple page. I'm going to put in header of web default view. And then I'm going to go to the next line. And I'm going to put a link called click here to page 2. And that's it. Now this section right here, this DHT11, we'll come back to that later because this is something I'm going to talk about getting data out of an Arduino. And then we hear server, we do a server print and we close the body in the HTML. So this is the default. So let's go look at the default page. Let's go bring up our page and we're going to go to our page 250. Oh, helps if I send the sketch up there first, doesn't it? It doesn't know that it's a web server yet. All right. All right, there it's there. And we'll go up here and we're going to stop this because it wasn't going to get it. And we're going to go to 250. There's our page. So here's my H1. Here's my link to page 2 and my text. Very simple. So that's all that one did. So let's go over here and look at the next one. And okay, well, default command basically calls default view. So default command just has some additional variables that aren't needed. So they're just trimmed off there. And then we come to page 2. And I, again, set the HTML header right here. See, it's exactly the same as the other one. Send out my 200 and then my header. And then I start with my actual content. So here I'm going to do a header again. This is page 2 with form. And then I'm going to do a div, which sets my maximum width and the margins. I'm going to create a form. We're all familiar with forms, which is where you put information in. And then I'm going to loop 4 times, basically 0 to 3. And actually, let me do this. Let me go 1 to 4 so it's less confusing. And then I'm going to print out name and then number. Then I'm going to print out whatever this I value is. In the first loop, it would be 1. Then I'm going to put out input type equals text. It's name and then again the number. ID is equal to name and then the number. And a maximum size of 16. Right here. And you see through all this, I'm using this F. That's why I covered it first, because I didn't want everybody to be confused what the F was doing and why it's so important. If you think about this, think about how much space this would take up. And this is just a very, very simple web page. So, all right. So after I go through this loop right here of printing out the 4 names, I'm going to print out the submit button right here. So you see, I basically put a paragraph break and submit. And then I close my form, the div, the body, and the HTML. So that was if I go to page 2. So let's go over here and actually let me upload this. So I made this change from 1 to 4. I want to make sure that it's in here. All right, so come back over to this page and we can either click here. You see down at the very bottom, if you can read it down at the very bottom, it says I'm going to go to page 2. Or I could just click here and just do /page 2. It's doing the exact same thing. Just like this. There's page 2. And you see it took a little while because it's, again, these Arduinos are not fast. So here's page 2 with form, and you see name number 1, 2, 3, and 4. And we're going to look at the source code real quick just to kind of demonstrate. So you see the text, there's everything you saw in the header so far. And then there's the head, the body, and then the H1s where I started. And then you see me putting out all this information. Then here's the form. And it's a post. That's important to remember in the next thing we're going to go through here. Then you see name number 1, which is from my loop. And then the name is equal to name 1, ID is equal to name 1, size, and it just keeps on going just like that. All right, so let's come back over to the code. We're going to look at the next subroutine, which is form command. So this is how I'm taking input. So the first thing I'm going to do is I'm going to say, was it a post? Because if it's not a post, that means the submit button was not pressed. Somebody went to this by going to /form and skipping the page 2 process. So I'm going to skip over this real quick. If it's a post, I do this work. But if it's not a post, what I'm doing is I'm going to send back page 2, because I'm assuming if you're trying to get to the form submission, you probably really want the page where you put the information in. So I'm going to send them back the page 2 command. All right, so come up to the top, and if it's equal to a post, I'm going to define a value called repeat, and we'll see why here in a second. And then 2 temporary variables called name and value. I go into a do loop, and if you're not familiar with the do whiles, basically a do will always do this one time, at least one time. So we come down here and we do repeat equals server read post parameter, and then name and value. So what happens when you read post parameters, you get to give it the place where you want to put the name that was passed in, and how long, what the maximum length is, the value where you want to put the value in the maximum length. So what this returns though is a true or false if there's more data to be read. So in the case where I was posting 4 names, I would actually be able to read this 4 times in a row. So reading the first time through, this would come back true because there's a number 2 coming up. Same way with 2 and same way with 3. But when I get to 4, it would come back false because there's no more data after that. So basically this reads the data into these 2 variables. Now here you're going to see me convert this, or went too far, to a string, a capital S string. So what this is a, I don't want to call it a library or a function set, but it's basically a library that allows you to do additional things to this. So you would normally have to write all this in a character array, which is what name is equal to. But by converting it to this string, and this string converts it right here as well, I can do things like this. Name starts with name. It just gives you some additional string variables and functionality. There's actually quite a few of these functions after the name. So I guess maybe it's considered a class. A string class, yeah, that's what it's called. And it's getting late. My headache's not back, but it's getting late. So anyways, what I'm going to do here is, you see I named everything with the first 4 letters always being named. Name 1, name 2, name 3, and name 4. So what this allows me to do is make it a very efficient code. Rather than saying if name is equal to name 1, then do this. If it's equal to name 2, then do this. I basically have this loop that I can go through and do it with just a little bit of code. So if it is name, then we're going to come in here and we're going to say, what name is it? So what we do here is we take name plus 4. So it's basically taking string. This is string to unsigned long. So what I'm giving it is where I want to start, and that is name plus 4. So 0, 1, 2, 3, and this would be the 4th. So it'd be the number, the default value of null, and the base. So it's going to come back with 1, 2, 3, or 4 in our case. And then when it does, I'm going to print out to the serial port name, number, and then the address, which would be 1, 2, 3, or 4, a colon, and then I'm going to put the value in there. And then we come down to the repeat. So remember I said repeat comes back true if there's more data. So we're going to do this loop at least 1 time. And if there's more data, we're going to go back and we're going to do it again. And we're going to do it again until there's no more data to be read. We only care about name, so there is going to be an additional one called submit, because that's my button, but it won't do anything because there's no value here. And then we have to give it an answer back. So what we do for the answer back is we say go to page 2. So this basically is sending back, I would almost call it a redirect for the most part, good to go to page 2, because that's where we want to go back to, the form we just left. And that's it. So let's go do the form real quick. And before I do that, I need to bring up the serial monitor so we can see that, because we're going to use this. You see I had a little bit left of my previous, and Oops, that's not what I wanted to do. I want to shrink this down so I can see both. Let's get this out of the way temporarily. All right, so now you see both the serial monitor and the page. And I'll put my name in here first, and we're going to hit submit. And there you see, well, it wasn't obvious. Let me do it again. Like I said, it's not the fastest. I will say the Mega is considerably faster, but still not overly fast. So, come on. Do 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 do. Not quite sure what shouldn't be taking this long. Let me do this. Let me get out of this. And bring it back up again. Alright, let's try this one more time. There we go. A little more clear. Don't know what took so long, but there it is. Mike is the first one. Now I can put on, I can do this. And we'll put Bob. We're missing Bob. I don't know. I don't know these people, but whatever. I don't know any of these people. So hit submit. And if all goes well, and it's not going well. There it goes. Mike, Bob, Susan, Joy. So you see we came back with the results. Again, these are not super fast, and this actually is much slower than the one it was on the Mega. So I don't know if it's something with my network that's going on, or if it's the Arduino itself. It seemed like it worked this slow before when I was in the other room working on it, and I was plugged into the same switch. So it could just be that the Unos are not super fast at it. All right, so let's do this. We're going to go back and, well, here, I'll let you see what I'm doing. Let me go back over to here. I have a DHT11 right here, and I'm going to plug it in. Let's first of all plug in the data. So it's 0. All right, plugged it into 4, and then I'm going to plug in power. And then I'm going to plug in ground. All right, so now I should have a DHT11. So let's go back to the very first page here and see what it does differently. Let me try something a little different. So this is like live in the middle of the show type of stuff. I'm actually going to change the IP address. Maybe my IP address is conflicting in here. I didn't think it was being used before, but maybe it is. Let's go to, well, and make sure. $251 is clear. Let's see, is 250 responding to me? No, 250 is not responding to me. So let me do this. Let me make it 251 because I may have a device that's actually at 250. And we're going to upload this. And we're going to stop this, and we're going to go to 251. Okay. Maybe there was. See how much faster that was? Let's see, page 2. I don't know, maybe not. All right. Well, we won't worry about the slowness part of it. This is something to keep an eye out for. So one of the things you'll notice right here, other than the fact that I misspelled temperature, I just saw that, is this is also another failure for this show. It now sees DHT11, but it's coming back at 0 Celsius. And trust me, it is not freezing in here. In fact, it's actually kind of warm. And 0% humidity. I hope it's not 0% humidity. But because it saw the DHT11, if you look back to our code and we come down into here, basically the DHT11 comes back equal to 0 if it has a valid value, which in my opinion is not valid. Freezing is not valid. But anyways, it prints out the current temperature in Celsius, then Fahrenheit, and then prints out the humidity. So this would be a way to get data out of the Arduino, just like this. And now that I think about it, maybe this is interacting with the Ethernet shield. I'll have to check that out. And if so, I'll mention in next week's show about what not to do with a DHT11 and an Ethernet shield. Because this is coming back 0 now, and the Ethernet's acting funny. So it's very possible they're interacting somehow. I'll have to check that out. But anyways, this is a way to get... Now, this is great for human readable, because you and I can read this and say, well, I know what it means. But it's not great for machine readable. So what do we do for that? Well, there's some things we can do, and I'm going to cover this in a different show, of getting data out in a format that other people can understand. One of them would be XML. So we could do another page that'd be like /XML that would turn out current temperature, things like that, and a machine can read that data and understand it. Another one is JSON, which is probably the more popular one I won't say more popular. It's definitely an easier one to understand if you're doing things in JavaScript, because it basically it's what it stands for. It's the JavaScript something notation, and I can't remember what the O stands for. But it makes it very easy for JavaScript to understand it. And if you're doing things in another web page to read data from a remote sensor, so this could be a remote temperature sensor. You can use any kind of sensor. You could use you name it. You can use accelerometers or things like that, and you'd be able to get remote data. So wherever your creativity leads you for a remote sensor, this is a way to get data out of it. And if it's only serving that purpose, it probably work just fine. Again, we have to figure out why it's so slow. And I will maybe experiment a little bit more with this to see if I can figure out why this particular Uno is so slow, or if it is because I have in the SPI stuff in here for the one wire. So I'll check that out and let everybody know the answer to that next week. So, but here you can see, it's another way of getting out data out of a web page, out of an Arduino. So if you don't want to write a protocol, don't. Just do a simple web server, put the data out. You saw me both get data out and get data in when I was submitting the form. So it goes both directions. And the form doesn't have to be in somebody's name. It could be something that's controlling. So in our show, we typically use a lot of buttons, and we use buttons to make certain things happen. So you could make this whole thing web-based, and you wouldn't have to have any physical buttons at all. You could hit a button on the web server that would turn on a certain pin, or move a servo. Anything you can do with a physical button, you can do with the web interface as well. Works very nicely, as a matter of fact, and it's a very easy interface people understand. And you don't got to be physically connected to it. You could put it somewhere, have it do something, all via a web interface. And just because you write a web server doesn't mean it has to be a human doing it. You could write a sketch on the other side that's calling the web server to do something remotely. It's just another protocol. That's all it is. All right, so we're at about 50 minutes, almost up to our hour point. So I think that's pretty much all I wanted to cover this week. And hopefully next week we have a normal show without all of the failures before the show. And get back on with us. So it's kind of weird not actually having him here after he was here last week. We're back to normal. Again, we normally record a show Monday nights at 9 p.m. This is Tuesday, because I was feeling really bad yesterday. I'm still not feeling great. My stomach's still not quite normal, but my headache's gone, so I can think fairly clearly, and I'm just a little tired. That's about it. So next week we should be back to 9 o'clock. So I also want to thank everybody for bringing your friends. Like I said, this show is going crazy. If you can watch us live, please do. We love to have you watch us live. I can't even stay in the chat room today. I can't tell if anybody was trying to watch it. It just keeps disconnecting me. It's sitting here next to me, and you see me every once in a while reach over and tap it, try to reconnect, and I connect it, and it gets disconnected again. So my internet's just all messed up today for some reason. So I think I need a call to Comcast in the morning if they're still having issues. So anyways, if you are watching us on YouTube, please click the like button. That's definitely always helpful to help us find other people, to help us find them. Put comments out there too, questions, whatever. Keep the emails coming. We're getting emails, and I know we're a little slow at responding, but we'd like to get them and get feedback. And all feedback is good, whether it's you don't like something or you do like something. We appreciate every comment that we get from people, and we take it very seriously. After all, this show is mainly about you. It doesn't, just because I could sit here and play with my stuff all day long and be perfectly happy with that, but I'd much rather help people and teach people and learn with people as well. So the more we can do that, the better off we are. So keep the comments coming. Ideas for future shows, please let us know. We're getting some. We have a bunch of shows coming up. I wouldn't say a bunch, 3 or 4 that are user suggestions and questions and things. One of them was a deep dive. They want us to come in and go into a more deep dive on something. Definitely willing to do that. Love to do that. And that kind of stuff. So definitely let us know. If you are watching us like on like a podcast of some kind, wherever you get your podcast from, whether it be iTunes or Podcatcher, what all the different things that are out there now, go out and click the like button. Help get us found a little bit more, and help us to grow the show on whatever medium you're getting it on. Our downloads are available. We try to make it everywhere. If you find somewhere that we're not, please do let us know, and we'll try to get there as well. We do have a Roku app, very popular Roku app actually, especially in the UK. For some reason, we're more popular in the UK than anywhere else. Well, not necessarily the US. Maybe it's kind of close. But we get a lot of activity off of the Roku in the UK for some reason, which is good. No complaints there. Maybe Roku is really popular over there. So anyways, come next Monday night. Hopefully Bob will be back, and hopefully we'll be able to connect to Bob. I mean, Bob was around tonight, and I do apologize to him for whatever the technology problems that we're having tonight. And hopefully next week we're all back to normal. All right. I think that's going to be it for this week. To see everybody next week.